Math 3, practice 2A.5.3. So we're finishing up our geometric series. So now we've talked about the geometric sequences. We've talked about the sum of a finite geometric series. Okay. Now we're going to talk about infinite. Infinite meaning they don't end. Okay. Finite, they had a certain number up here. Infinite, notice it's to infinity. Okay. Or it just keeps going. Just keeps going. Okay. So, first thing, a few things to talk about. Okay, we've got these two words, converge and diverge. Okay, thinking about that formula, our a sub 1 times r to the n minus 1. Okay, converging means that the graph is going to have, the infinite geometric sequence is going to have an answer that it gets to. Okay. And we know that by checking the value of r, okay, that rate, what we're multiplying by. If it's less than 1, it's going to converge and it will have a sum, okay, which will equal a number. Now if it diverges, okay, that's when the rate is greater than 1, it's not going to have a sum, okay, because it's not going to get close to a number. A good way to think about it is that exponential equation. Okay, diverging would look like this. As I look to the right, the end behavior of this is going to keep going up. Okay? Whereas, if we look at the converging one, it's going to come down. And the idea here is that it's getting closer and closer to something. Okay? So those numbers are getting smaller and smaller and smaller, so that it will eventually get close to something. Okay? When you add these all up, it'll get close to something. So that's the idea. So when r is less than 1, when it's greater than 1, it's divergent, it has no sum, we call it good. When it is less than 1, okay, it is getting, so it's like a fraction basically, you know, between 0 and 1. We can get it by using this formula, okay, the summation formula. And it'll look like this, okay. This is what the infinite looks like. It has infinity here. We're used to seeing a number up there, okay. That won't be the case in this one. And when it had a number, we used the calculator or we used this summation formula. Notice that it's different than the new one for infinite. Okay, this is for infinite, this is for finite. So infinite, we drop the 1 minus r to the n, essentially, and we have the first term, the rate, and we can use this formula to find it. Alright, so let's take a look at this. So number 1, okay, first thing we should notice, it is infinite. Okay, remember that 3/4 is our a sub 1. That 1/2 is our rate. Okay, is the absolute value of 1/2 less than 1? Yes, it is, because 1/2 is less than 1. So what that tells us is that we do have a sum. Okay, we do have a sum. So we need to use that formula. So a sub 1 is 3/4, so I go 3/4 over 1 minus our rate is 1/2. Okay, and that's what we use to figure out what our sum is. Okay, so we take a look at our calculator, and 3/4 is like 0.75. It's easier to write. 1 minus 1/2, well, that would be a half, right? Or 0.5. So we have 0.75 divided by 0.5. And when we type that into a calculator, we get 1.5 for answer 1. So this infinite series has a sum. When we add it all together, eventually it gets to 1.5, or really, really close, so that's what we would call it. Okay, now number 2, same idea, we have this infinite, okay, 3/5. Is 3/5 going to be less than 1? Well, 3 is smaller than 5, so yes, the answer is yes. Okay, I believe that's like 0.6 or something like that. Okay, so we then use our formula. A sub 1 is 5/6. So I go 5/6 divided by 1 minus 3/5. Okay. Now, we can just type it into our calculator like that. We could simplify. This would be like 5/5. 5 minus 3 would give us 2/5. And 5/6. Remember, when we're dividing fractions, probably learned that if we multiply by their reciprocal, it's the same thing. So times 5/2. So we'd get 25/2 12, which would be like 2 and 1/12. Okay. Or we could just, use a calculator and figure that out too, which would give us a decimal of 2.083 repeated. So could write it 25/12 or 2.083 repeated. The 3 is repeated. Alright, so now number 3, now this didn't give us 1, but this would be a sub 1, right? Okay, now what are we multiplying by? Okay, because of those dots we know it's infinite, it's going to keep going. Well, how do I go from 1/10 to 1/9 to 10/81? Okay, so how is this growing? Okay, so from here to here we'd have to multiply by 10, right? Because 1 times 10 would give us 10. And here, 9 to 8, we'd have to multiply by 9, because 9 times 9 would give us 81. So is 1/10 times 10/9 going to get us 1/9? Well, that would be 10. That would be 90. Yeah, 1/9. So R, A is 1/10. R is going to be 10/9. Okay, is 10/9 less than 1? Okay, well, 10 is bigger than 9, so that's like 1 and 1/9, so the answer would be no, right? So we like it when this happens because that tells us there is no sum here. Okay, no sum, and we call it good. Alright, now this last one, okay, 0.03 to 0.003 to 0.00003, so we're adding 2 zeros each time, aren't we? Okay, basically. So what would we multiply by to get that to work? Well, if you're not sure, take this one, divide it by that one. So when we do that, we find that we're multiplying by our R is 0.01. Is 0.01 less than 1? Definitely is. So we have a sum. Okay, and our first term, a sub 1, is 0.37. So we go 0.37 divided by 1 minus 0.01, which that would be 0.37 divided by 0.99. Type it into a calculator and we'll get our answer. And we get that 0.37 repeated. Okay, so our answer would be 0.37 repeated. We could also write that as 37/99 if we wanted a fraction instead. Either one works. Okay, now 5 and 6 says use the formula for an infinite geometric series to rewrite each repeating decimal as a fraction. So in other words, a sub 1 over 1 minus r equals this. So the way to think about this is you'd have like 0.7 plus 0.07 plus 0.007, okay? Because that whole thing's being repeated, it's like 0.7777, so we take the 10th, the 100th, and we split it up as if we were adding, okay? So how do we get from this to this? By timesing by 0.1, okay? So there's our a sub 1, there's our r, so then we'd go 0.7 divided by 1 minus 0.1. 1 minus 0.1 would be 0.9. 0.7 over 0.9. We could times them both by 10. That would give us 7/9. Okay. Now, same idea. Okay. That's 0.345 plus 0.000345 because it's repeating, plus 0.000000345. Okay, so there's a sub 1. So that would be 0.345 over 1 minus, now what's our rate? Take this, divide it by that. I believe it'll be 0.001, but let me double check that. And I was correct, so our R is 0.001, okay? So it would be 0.345 over 0.999, which we times these both by 100 or 1,000. I think by 1,000, wouldn't it be? Okay, we'd end up with 345 over 999. All right. Okay, now number 7 and 8. Use the following information to solve problem 7 and 8. An experiment to determine the rate of decay for a certain radioactive isotope starts with 1,000 milligrams of the isotope. After 1 hour, only 995 milligrams remain. Write an infinite geometric series to model the rate of decay of the isotope over time. So, we start at k equals 1. We're going to infinity. Okay, our starting number, our a sub 1, is 1,000. Now, what are we timesing by? Okay, we multiply by something. So we made a table. 1 was 1,000, and then after the next hour, we only have 995 left. So, we take this, divide it by that, so 995 over 1,000, which ends up being 0.995. That's what we're timesing by, 0.995 to the k minus 1. Okay, so that's number 7. The number 8 says to evaluate it. So remember, this is less than 1, that's our rate. So we go S sub n equals a sub 1, which is 1,000, over 1 minus 0.995. And we get our answer from that. So it would be 1,000 divided by 0.005, right? Which, when we do that, we get 200,000. And there we go. Alright. So now it says, use the information for 9 and 10. Fractals are very detailed geometric figures made up of repeating self-similar patterns. Each small section or stage of the figure is the same shape as the entire figure. For example, the following illustration shows stages 0 through 4 of the Koch snowflake. The original stage 0 is constructed of an equilateral triangle. Then each segment of the triangle is divided into thirds. So they divide it into thirds. And they create a new equilateral triangle. And then they just looks like they eliminate that part. So they just keep doing that. So they're just building more and more triangles, okay? So it says, write a geometric series for the area of the stages of the Koch snowflake. Hint, use the area formula for an equilateral triangle, which is a equals s squared times the square root of 3 divided by 4. Alright, this one's kind of crazy. So S stands for the side length. Let's just start and call each of these 1. So our side length would be 3, all of them added together, right? So we'd go 3 squared times the square root of 3 over 4, which we'd simplify to 9 square roots of 3 over 4. Okay, that would be our first number, a sub 1. Alright? Now we've got to decide how this is, what rate we're multiplying by. So we know we started out this way, 9 square roots of 3 over 4 times the rate to the k minus 1. K equals 1, and we get the infinity sign. Alright, now I was trying to figure out what r was, and I had a lot of issues trying to figure out what r was. Okay, so let me take you through my thought process, because that proved to be very difficult, because r actually ends up being 4 over 9. Okay, the reason is, going from this area to this area, we're multiplying by r, correct? Okay, well, what I did was I realized that this stage 1, if I cut, let's see, no, let me write it the right way. If I created stage 0's shape, I've only got 3 more pieces, okay? So, if we're looking at finding the areas of these plus that, we end up with 1 square root of 3 over 4. Because when I add up all these 1/3, we end up with our, no, that's not how I did it. Hold on. That was a, okay. So then if we kept splitting these up, that's what I did, you end up creating, of these smaller triangles, you end up creating 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of those smaller triangles. So those smaller triangles are 1/3 and 1/3 and 1/3, which 1/3 plus 1/3 plus 1/3 is 3/3, or just 1. So I get 1 square roots of 3 over 4 for the area. But I have 12 of them, so I times them by 12. And if we take this and divide it by that area, that'll give us what R is. So the area we started out with, 9 square roots of 3 over 4. So I divide, okay? But we can't divide fractions, so we multiply by their reciprocals, okay? But what I don't want to do is, I don't change the other one, but 12 can be split up to 3 times 4. 4 on the bottom, 4 on the top, 4's cancel out. 3 multiplies, we get 3 square roots of 3 over 1 here. So now the square root of 3 on top and bottom cancel out. 9 is like 3 times 3. 3 on the top, 3 on the bottom cancel out. And I'm left with 4/3. So what am I missing? Damn. This is very difficult. So somehow there has to be a 3 under here still to make this all work out. I'll have to think about that a little more. I thought I had it worked out, but I must not have, unless this is supposed to be 1/3 or 1/9. Then that would give me 1/9, because it'd be 1/3 squared, wouldn't it? Yeah, just like we had 3 squared. So that would be 1 over 9, and then 3 times 1 over 9 would give me 1 over 3. So I'd have 1 over 3 times the square root of 3. Then the square root of 3's would cancel. I'm left with the 9 right here, and that would give me 27. Alright. Well, regardless, that's not part of the problem we're actually doing. That's something different. So we'll just go with this as our geometric series piece. Okay? Then what we're going to do is we are going to, so the whole idea is that we can take this and we can use that to then evaluate it. That's really the whole point. So forget about all this other crap. Okay? So now, to evaluate the series, right? 4 over 9. 4 is less than 9, so it's less than 1. So we've got a sub 1, 9 square roots of 3 over 4, over that 1 minus 4/9. Alright. Now, normally I just say type it into the calculator, spit out the answer, and go from there. But if we really wanted to, that could be like 9 over 9. 9 minus 4 would give us 5 over 9. Dividing into 9 square roots of 3 over 4. Okay, remember, if we multiply by the reciprocal, we get the same answer. So that would give us 20. And that would give us 81 square roots of 3. Okay, which we can't really simplify that, can we? So if we did type it in, we'd get 7.0148. Okay, so either one of those would work. So the whole point, can you take that and find this? That's really what we're asking. To find this from this crap, forget that. That was way too confusing for me, because it didn't seem to work the way I wanted it to. But anyway, there we go, guys.